Good morning. So first off, you should be watching this through Delta Math, okay? This video is linked through Delta Math. Watch it and follow along with the notes. I won't be collecting the notes, but in order to get full credit on this, your video will need to be completed on Delta Math. That means if you are watching this through YouTube or on a friend's Chromebook, you won't get credit for this. So go to Delta Math, sign in, click play, and watch it through in its entirety. If you skip 2 minutes of it, then that chunk will be missing and you won't get the full credit. So watch it. I'll try to keep it as short as I can, but today we are going to start by talking about how we would go about graphing these wave functions. Now, we're going to talk about what these represent. We're going to be graphing sine, cosine, tangent, cotangent, secant, and cosecant in the last part of this chapter. But today we're just going to be analyzing these wave functions and talking about three important characteristics: the midline, the amplitude, and the period of these wave functions. Okay. Tomorrow I'll be back. Today I was planning to be on already, so I just kept it because I couldn't quite change plans. But tomorrow I'll be back and we'll pick up and talk about specifically sine and how to graph that. So get through this video and then complete the delta. I think you'll be able to get this done before you leave today. Assuming that it's a normal day today. I guess if it ends up being a 2-hour delay, it might be tough in the time, but let's get this done, if possible, before Friday so that Friday we can build on this. So, other piece of news, you probably saw in my message, unfortunately we're going to have to cancel our quiz for the first part of Chapter 6, so sorry about that. I know some of you were really looking forward to showing me what you know, but you'll get a chance on the test. So, let's start by talking about our midline, okay? So your midline will always be a horizontal line, meaning it's going to be written as y equals, okay? And for our horizontal line here, our definition here of a midline, it's a horizontal center line about which the function oscillates above and below. Okay, if you don't know what oscillates means, basically it bounces back from one side to the other of it. Okay, so let's start by analyzing on our first graph here where this midline is. And I'll draw this in red and I'll draw it dotted. If we look here, our midline for this particular graph is going to be at y equals -1. Okay, so let's talk about why that is. So y equals -1. Okay, so first off, if we look here, if it's the midline, the distance to the peak, 1, 2, 3, the distance to valley, 1, 2, 3, those two distances should be the same if it is truly a midline. Okay, this is saying the highest we get and the lowest we get are equidistant from this midline. Okay, so y equals -1 would be our midline for this one. Okay, for our second one, we look here. And we say, okay, the highest point here is at 4, the lowest point here is at 0. We want to find the midpoint halfway in between that. Okay, so that's one way you can think about it, find the average of your high and your low. Most of us can probably do it visually and don't necessarily need to do that. So for this one, it's going to be at y equals 2, because 2 above that is 4, 2 below that is 0, both the high and the low. Okay, so that's midline. Our second characteristic, amplitude. Okay, so for amplitude, this is going to be our distance from the midline to the peak or to the valley. So another way to put that is it's the distance from our midline to your highest point, your maximum, also known as like your peak, and it's the distance from the midline to your valley or your lowest point, your minimum. Okay, so if we look here, and that will be the same. The reason I can say or, it's going to be the same for both of those. So if I look here, we already talked about this. How high is the max above the midline? So I don't put 2 as my amplitude. My amplitude here is 1, 2, 3. And it's also 1, 2, 3 below. Okay, so here amplitude is, our amplitude is 3. And for this one, our amplitude is 2 because the maximum is 2 above, the minimum is 2 below. Okay, our last thing, our period. Okay, what does a period mean? Well, in school we have periods to represent our different classes. Okay, if any hockey fans out there, go Avalanche. If you're any hockey fan, though, the 3 periods represent the game, right? It's kind of like in other sports it's quarters or halves, but in hockey it's periods. So basically it's one cycle. So what do I mean by that? So the period is the length of one cycle of the wave. Okay, now another way to think about this, you might want to mention, is peak to peak, or if you want, you could do valley to valley. And I'll show you what I mean by that in just a second. So, one cycle of the wave. Now, let's start up here, and you might want to just watch for a moment. Don't necessarily draw this on yourself, but I'm going to highlight this, and I'll use green so it stands out. Okay, so I'm just going to start at our y-axis, and if I start here, it goes up and then down and hits the midline again. Now, that is not one complete cycle. What do I mean by a complete cycle? Basically, if I have a complete cycle, if I take it as a stamp, I can stamp again and again and again, and I'd get the rest of the function by moving it left or right. Okay? So that only represents the top part, the part above the midline. Okay? To complete my cycle, I also need this part below. And do you guys see what I've highlighted in green? That represents one cycle, and we'll talk more about what that means tomorrow with sine, but that's one complete cycle of our pattern. Okay. Now the thing about a wave function is a wave function just continues both to infinity and negative infinity as repeating the same thing again and again. If I take this green little stamp here and I move it right and I stamp it and I keep moving it right, I can stamp the same pattern again and again till infinity. And I can also do it to the left. So if we look here, what does it take for one complete pattern? From 0 to pi over 3. Okay. Now that means what is my period here? Pi over 3. Okay. Now the other way to do this, if you prefer, is you can do what we call peak to peak. Okay. So what I did worked, but we also could have done from this peak to this peak, because peak to peak will represent one cycle. You only hit the peak once per cycle. So if I do peak to peak, that's the start and the end. Now, you might look at this and say, well, if that's the case, then our answer is 5 pi over 12 for the period. False. If you said 5 pi over 12 is your answer for the period, that'd be like saying, okay, how tall is Mr. Fox? So I stand up on a chair and you guys measure me and we say, oh man, Mr. Fox is like 8 feet tall. No, to get my accurate height, if I'm standing on a chair, you would have to subtract the height of the chair, okay? So, in the same way here, if I go peak to peak, I could have 5 pi over 12, but I'm going to need to subtract pi over 12 from that. Okay, now if I do that, 5 pi over 12 minus that pi over 12, that leaves me with 4 pi over 12, which reduces to pi over 3, which is the same answer. So that's two different methods on how you can do it. It doesn't matter to me which way you do it. Now on this particular problem, the one below it, example 2, it's going to be the same either way because this one starts at a peak on the y-axis. So peak to peak comes down here, and that means one cycle completes at 4 pi. This one has a period of 4 pi. Now if you wanted to think about it the way we showed peak to peak, you also could say 4 pi minus 0, which will also be then a period of 4 pi. All right. At this point, if you want, pause the video and take a moment and see if you can answer the ones on the back and see if you can get these right. Once you're ready, take a look at it. So we'll go ahead and talk about our answers here on the back. So if you need a second, pause the video and try it out. So this one on the back, the midline is going to be here at -1. Y equals -1. Okay. Our amplitude, 1, 2, 3, 4 above, 1, 2, 3, 4 below, our amplitude is 4. Once again, if you get an amplitude that is not the same up and down, then it's not really your amplitude. You made a mistake. And then finally, your period. To do this, we need to highlight one cycle. And you don't have to draw that on, but I think for some of us it's helpful. That first cycle would finish at 2 pi, so 2 pi is our period. Okay, on the second one, the midline here at y equals 3, your amplitude just 1 up and 1 down, so that's an amplitude of 1, and your period starts here, completes our cycle at the next peak. That is a period of 2 pi. All right, at the bottom, keeping it on. This time, the midline is going to be here at y equals -3. Your amplitude up 2, down 2, amplitude of 2. Your period, 1 complete cycle. Remember, that's not a complete cycle, that's just the top part. We also need the bottom part right here at pi radians. Okay, so that's 1 cycle or 1 period. And our final one then for this one, and once again, you probably can see it. You might not have to draw this in, but our midline there at y equals 0. Our maximum is 5 above that. Our minimum, 1, 2, 3, 4, 5 below that. Okay, and then finally our period, we think about it, starting here, it goes up, and then it also has the down part, and so that's going to be 10 pi over 3 is our answer. If you prefer the peak-to-peak method, you could have done 25 pi over 6 minus 5 pi over 6. That's going to leave you with 20 pi over 6, which if you reduce is then 10 pi over 3. So that's the video. Go ahead and complete the delta analysis. Tomorrow we'll talk about sine. Hope you guys have a great day, and I'll see you soon. Bye.